Okay, so today's lesson is lesson number 55. This is solving three variable systems. Okay, so we've been working with systems of linear equations that had two variables, so like x plus y equals 3 and x minus y equals 4. Okay, so we had two equations with two variables. Now we're going to have three variables, so we need three equations. And these can be helpful, just like how we had word problems with the two variables. We have problems that we could figure out using these systems too. So we had a problem on Friday that was, say, how many students are in each van and how many students are in each bus for the field trip. So what if there wasn't just vans and buses? What if there were sedans too, or a certain type of car? So if you have three different things that you're looking at or trying to find, that's where these three variable systems come into play. So we're going to work with those today. These are the steps if you weren't in class to write them down. So the first thing you're going to do is use substitution or elimination to create a system of two equations and two variables. So we're going from three equations. We need to somehow combine them so that we can narrow it down to two equations with two variables. So we're going to eliminate the same variable from the three equations. Then we're going to solve that two variable system that we created and substitute those two values into one of the original equations to solve for the third variable. Just like with our systems of two equations, we will end by checking our solution. We're going to plugging in those three values into all of the equations, okay? Okay, and then we're actually going to start with this example. I know it says number 3, but we're going to start with this one first. So the first thing I'm going to do is label my equations 1, 2, and 3. Okay, then I'm going to look and I'm trying to figure out which variable would be good to eliminate. Okay, and I see the x's all have kind of a different value in front of them, so do the y's, but the z variable in each of these just has a coefficient of 1. So for my first step, when I'm trying to create a new system with just two variables, I think it's going to be easiest if I try to eliminate that z first. So I'm going to start by rewriting equation 1 and equation 2 on top of each other. I'm going to eliminate the z in those two. So rewriting equation 1 and rewriting equation 2 right under that. Okay, so I see that if I add these together, I'm going to be able to eliminate the z, right? So that gives me negative x plus 4x is 3x, 4y plus negative 5y is negative y. The z's cancel out. I get that equals 13. Okay, so now I have one equation that's just in two variables. So I want to combine another two of the three variable equations, eliminate the z again, and create a new two variable equation. So now I'm going to take equation 1 and equation 3, combine those together. So if I rewrite those on top of each other, again I have a positive z in equation 1 and a negative z in equation 2. So those will eliminate nicely. So I add this second equation. Negative x plus 5x is 4x. 4y plus negative 3y is just plus y. And the z's cancel out. And then I have that equals 15. Okay? So first I took equation 1 and 2 and eliminated the z. Then I took equations 1 and 3 and eliminated the z. Okay, that gave me these two new equations that are just in two variables now. So I'm moving on to step 2, which is to solve that two variable system. So I'm going to solve for x and y now. So these are like equation 4 and 5. Okay, I'm going to stack these two on top of each other now and solve for these two variables. So I see right away the y's will eliminate if I just add those two together. So I'm going to add these equations. Y's cancel. I get 7x equals, oh, sorry about that. Okay, so I get 7x equals 28. Okay, then dividing by 7, I get x equals 4. Okay, so that's my first variable is solved for. Okay, now I'm going to plug that x back into one of these two equations, right, that just have x and y. Okay, so if I plug that back into the first equation, I get 3 times 4 minus y equals 13. So 12 minus y equals 13, which tells me negative y equals 1, so y equals negative 1. Okay, now I have two of the variables solved for, and I can move on to my next step, which is step 3, to substitute those two values into one of the original equations to solve for the third variable. So plugging x and y into the first equation, I have negative 4 for x plus 4 times negative 1 plus z equals negative 8. Okay, so that reduces to negative 4 minus 4 plus z equals negative 8. So negative 8 plus z equals negative 8. Adding 8, I get z equals 0. Okay. So my solution is 4, negative 1, 0. And again, just like how I can write x comma y as my solution for a two-variable system, I can write these three all together like x comma y comma z if you want. So that's what's up at the top, the 4, negative 1, 0. If you want to give that as your solution, you can, or you can write them each separately how they are here. Okay, it's up to you. Okay, so going back to problem 1 now, let's work through this problem. So I label my equations 1, 2, and 3. Okay, so again, I'm looking at the values in front of the variables. I want to see what's the best choice for my first variable to eliminate. I see in the x's I have positive 2, negative 2, and positive 2. So I think that might be a good variable to try to eliminate. So I'll start by combining equations 1 and 2, and so I'll rewrite them. So 2x minus 2y plus 3z equals 12, and negative 2x minus y minus 3z equals 0. Okay, so if I add these two together, I will be able to cancel out the x's, right? Negative 2y plus a negative y gives me negative 3y. Then positive 3z plus negative 3z, those actually cancel out as well. So that's a little different, right? We have two of our variables already eliminated. And that's actually okay. Okay, so this might happen. It's actually nice because now we have negative 3y equals 12. So I can divide by negative 3. And I already have one of my variables solved for. Right? So I have y equals negative 4. Now, if I plug that y value into two of my original equations, I'll end up with equations that just have x and z, correct? Right? So if I plug in y equals negative 4, these y values turn into numbers, right? So I just have x and z. So that's what I'm going to do now. So I'll plug this in. So plugging it into the third equation, I have 2x plus negative 4 for y minus 5z equals 0. Okay, and then simplifying that, I get 2x minus 5z, and then adding 4 to the other side, I get equals positive 4. Okay, so now I have one equation in two variables. I just need one more. So I'll take another one of my original equations. Again, that was equation 3. So let's look at equation 2 now. Plugging in negative 4 for y. I have negative 2x minus, and then negative 4 instead of y, minus 3z equals 0. And that gives me negative 2x plus 4 minus 3z equals 0. Subtracting 4 to the other side, I get negative 2x minus 3z equals negative 4. Okay, so now I have two equations in two variables. Okay, Okay, so I have these two equations. I'm going to combine them now and do a system of two equations with two variables. So rewriting them, I have this. Okay, and I see I have a positive 2x and a negative 2x, so I'm going to add these together. And my x's are eliminated. I'm left with negative 8z equals 0, so z equals 0. Okay, now I have two of my variables solved for, so I can plug that back in, those values into one of my original equations. So, see, plugging into, say, equation 2, I would have negative 2x minus a negative 4 for y minus 3 times 0 for z equals 0. Again, I'm just plugging in y and z, the values that I found, into equation 2 to solve for x. So I get negative 2x plus 4 equals 0, which just tells me negative 2x equals negative 4, so x equals 2. Okay, just simplifying that. Now I have all three of my values solved for, so I can write my solution 2, negative 4, 0. And then in green, those are my checks. I was plugging in those three values into the three equations to make sure that it holds true in all three. Okay. And for this x value, I could have actually solved for it by plugging in z into one of these two equations as well. Okay, that might have been a little faster, right? I could have just done that instead, but I was thinking since I had two of the variables solved for, that I should solve for the third. Okay, so we're going to do one more example. This is number 2. Okay, so labeling my equations 1, 2, and 3. I'm looking again which variable is going to be the easiest to eliminate. I see z again. I just have a coefficient of 1 or negative 1, so that's probably going to be a good one to eliminate. And then if I look closer at equation 2 and 3, I see that I have a plus 2y plus z in equation 2 and a negative 2y minus z in equation 3. So I'm thinking if I add those two equations together, I'm going to get two variables canceling out again, like the last problem. So I'm going to go ahead and start with that. I'll rewrite these equations. Okay, so I'm going to add these equations and I will get a 5x minus plus a negative x will give me 4x. Positive 2y plus negative 2y cancels out. Positive z plus negative z cancels out. I'm left with 4x equals negative 24 plus 8, which is negative 16. Dividing by 4, I get x equals negative 4. And again, I already have one of my variables solved for. So I can plug that value in. If I plug that in for x in any of these equations, this part now becomes a number, and I just have equations in two variables. So I'm going to go ahead and do that with equation 1 and equation 2. So I'll rewrite those equations, just plugging in negative 4 for x in equation 1 and equation 2. Okay? Okay, so that's what I get when I plug in negative 4. Then simplifying equation 1, I have negative 5y plus z. And then I'm adding that 4 to the other side, okay, to get equals 24. Okay, then in the second equation, simplifying, I get 2y plus z equals, I have a negative 24, and then I'm going to be, this is a negative 20, so adding 20 to the other side, I have negative 4 left. Okay, so then 5 times negative 4 gives me negative 20. Adding that to both sides, I get negative 4 on the right-hand side. Okay, so then I'm going to combine these two equations with elimination. I'm going to subtract the second one to get rid of the z. So I have negative 5y minus 2y is a negative 7y. Positive z minus positive z cancels out. Then 24 minus a negative 4 is like 24 plus 4, so I get negative 7y equals 28. Dividing by negative 7, I get y equals negative 4. And now I have two variables solved for. Here I'm just going to plug this in to one of these two equations. I'm going to plug that value of y in so that I can just solve for z. So plugging into the second equation, I have 2 times negative 4 for y plus z equals negative 4. Okay, then solving this, I get negative 8 plus z equals negative 4. Adding 4 to both sides, I get z equals 4. And all of my variables are solved for now. So I can write my solution, negative 4, 4. And checking my solution in each of these equations. First equation, I get 20 equals 20. In the second equation, I get the left side equals negative 24. And the third equation, I get 8 equals 8. So it works in all three, so this is our solution. Okay, so go ahead and look through these examples carefully to help you with your homework. Okay, go through. You remember you are always wanting to try to eliminate at least one of the variables and get two equations in two variables first and then solve for each of your variables. Okay, so that's all for today's lesson. Thank you guys.